Hello and welcome to linear, quadratic, or exponential.
That was our Halloween special. Okay, so we've got three different types of graphs here and three different types of equations. We know that the graph of a linear looks something like this. We know it's going to follow the line of something y equals mx plus b. A quadratic is going to look something like this or like this, and it's going to have y equals something with x squared in it, and maybe some more stuff too. Exponential is going to be coming down like this if it's decay, or up like this if it's growth, and we know it's going to be y equals like a number like 5 to the x, where x is the exponent. So we've got three different categories of graphs or equations, and what we're going to look at today, our task is to figure out how we could determine which of these models it is if I just have a set of points, if I just have x's and y's. So to start off, I'm going to let you copy down information here about linear functions, quadratics, and exponentials. Go ahead and pause the video while you write this down. And restart the video, and I'll come back to the problems. If you didn't pause, I'll go back and pause. All we need to look for here is the differences in the numbers. So if you look at the x's here in this first one, 0 to 1 is 1, 1, 1, 1. Fantastic. The y's, 2, 7 minus 5, 9 minus 7, 11 minus 9. And you notice that these first differences, these differences are all constant. It's all the same number. And these are all the same, which means that the change in y over the change in x is 2 over 1, which tells us that the slope is constant. It's a constant rate of change. So the kind of equation or the kind of graph that has a constant rate of change is linear. So if you look at this and you see that this is a constant difference, and this is constant, and when you divide it, it's constant, we know that that's a linear function. Let's look at the next one. This also is increasing by 1. I made them all like this to make it easy today. If we subtract here, 7 minus 5 is 2. 13 minus 7 is 6. Uh-oh, those aren't the same. 23 minus 13 is 10. This is 14. This is 18. So what you notice here is that these are not the same. So it's not a constant rate of change, which rules out that it can't be linear. It could be quadratic maybe, or maybe exponential, but not linear. And here's where we test next. Next, we're going to take the second differences. We're going to subtract these ones. 6 minus 2, 10 minus 6, 14 minus 10, 18 minus 14. Ah! Our second differences are a constant rate. So when this happens, if you look back at your notes, quadratic functions have a constant second difference. So this is going to be the kind that's like this. It's going to have something with x squared in it. This is a quadratic. If the second differences are constant, if they're the same. Okay, next example. On down here. Do the same thing. 1, 1, 1, 1. Here we have 8, and then, what's this, 24, and then, oh goodness, I need a calculator. 108 minus 36, can someone help me? 108 minus 36, and then 324 minus 108. Can I get some calculator help, a friend?
Look it out, bud.
So we've got 108 minus 36, I'm thinking 72.
Yeah, 72.
Thank you. And then 324 minus 108.
216.
Thank you. 216. All right. So we've got a non-constant rate here, so it's not linear. Okay, well, the teacher says I just subtract these. That's 16. And that's, oh, I need more help. I'm thinking 50, maybe 48. And then, well, 216 minus 72 in my head. 100 and...
144.
144. Okay, thank you. Uh-oh, the second differences aren't constant. They're not the same. So I need a different strategy. My first differences aren't the same. My second differences aren't the same. The thing to look for then is, what about ratios? What if I divide them? If I take, in this one, I have 12 divided by 4. Actually, even 24 divided by 8. Or actually, this is, yeah, we could take 24 divided by 8, and that's 3. How about this one? 72 divided by 24. Hey, that's 3. 216 divided by 72. Hey, that's 3. If I find that there's a constant ratio and when I divide them, it basically means I'm taking this number times 3, this number times 3, this number times 3, this number times 3, this number times 3. We're not having a constant rate of change, it's an exponential rate of change because every time there's a multiplier here of 3. And if that's the same, then we can say this is exponential. Now if this ends up being different, if it was not constant, then we would say, hey, it's not linear, it's not quadratic, it's not exponential, this is just other, it's neither, it's none of these things. Okay? So here's one for you to try. Try me. And I'll pause the video. You should pause the video now and try this. And now restart the video when you're done. And you should have gotten the answer of quadratic. If you got it right, you can stop, turn it off, your homework's done. If you need explanation, hang on and I will explain for you. So here we've got, this is 6, this is 10, this is 14, this is 18, no, yeah, 18, and this is 22. Not the same, these are all ones, but when I find the second difference, 4, 4, 4, 4. Second difference is constant, so which type is it? Quadratic. Have a great day.